Here we have an interesting piece of glassware that you'll find in most labs. It's called a separatory or dropping funnel. As you can see, many of them are conical. This one's cylindrical. Some even have some little extra tubing to balance pressures. So we're going to use this as a separatory funnel. We've got Lugol solution, this brown solution, a mixture of potassium, iodide, and triiodide ions. And there's some elemental iodine in there too. Here's a bottle of Lugol's original solution. They call it original because they have a picture of Jean-Auguste Lugol, who developed this in the 1830s as a medicinal treatment. It's a way of getting elemental iodine into an aqueous solution. The iodide ions react with the iodine and makes a triiodide. And this keeps everything floating around in the solution. But we're going to end up trying to get this iodine out of the solution using the separatory funnel. This is an aqueous solution, but now we're going to add a clear nonpolar solvent, in this case hexane. The iodine will start to preferentially dissolve in the nonpolar hexane. So you're seeing a little bit of purple in that top layer. The funnel will be capped and then shaken vigorously, so all the ions and substances in the solutions will get a chance to see if they'll dissolve in the nonpolar hexane or the polar water. They open the valve to relieve some pressure that might have occurred when mixing, and now they get a chance for the water with its strong hydrogen bonding and the hexane to separate. The diatomic elemental iodine is dissolving here in the hexane, and you see it as being purple. Now they're going to open up the cap and then do the separatory thing. This bottom layer of water with its very polar molecules will attract the ions with a dipole ion attraction. So in our beaker, you'll find the denser water and the potassium and iodide ions, making a potassium iodide solution. Above here we have the separatory funnel still with the nonpolar hexane in it, and that nonpolar hexane has attracted with its IMFs the elemental iodine, which makes this solution purple. As a result, we've managed to separate the nonpolar elemental iodine from the Lugol solution.